Okay, everybody, in today's lesson, we're going to be studying chemical formulas. Okay, that's what we're going to be doing. We're going to learn how to write chemical formulas. Okay, now we've got Rachel here on the mic, and she's perfect for this. Why? Because she doesn't even know the basics, right? So it gives me an amazing opportunity here to be able to explain this from scratch. Okay, so it doesn't matter what level you are, hopefully you're about to understand this. As long as you understand how to draw atoms. And I'm assuming, Rachel, you know how to draw atoms, right?
Yes.
Yeah, are you sure, yeah?
Yes,
So,
I'm sure.
so if I asked you for sodium, yeah, sodium has a mass number of 23 and an atomic number of 11, right? How many protons does sodium have? Okay, now, the bottom number here are protons, right? The atomic number. So we have 11 protons, yeah?
Mhm.
And the top number gives us the number of protons plus the number of neutrons, yeah? So if you have 11 protons, how many neutrons must we have? Of course, 12, right? Because 11 plus 12 gives you 23, right?
Yes.
So how many electrons do we have? 11, because the number of protons always equals the number of electrons.
Electrons, yeah.
Is that understood?
Yeah.
So we're going to draw a sodium atom real quick. How many electrons does sodium have in its first shell? 2. It's only allowed 2.
Yeah.
Okay. In the second shell, how many is it going to have? 8. It's only allowed 8. In the first shell, it's 2. In every shell after that, it's 8. How many electrons have we got so far, Rachel? Count, Rachel. We've got 10.
10.
Yeah. How many more do we need? 1 more. Now, sodium wants a full outermost shell. So ideally, he wants to get rid of this electron here. Do you know why he wants to get rid of it? So you can have a full outermost shell.
Yeah.
Yeah? Now, who's it going to give that electron to? Well, metals, yeah, bond with non-metals. So do you know where the metals and non-metals are on the periodic table? This is the periodic table, okay? We have the metals, right? We have the staircase here, okay?
Mhm.
The metals on the left side of the staircase and the non-metals on the right side of the staircase, okay? So metals react with non-metals. And when they do this, they always give away an electron or electrons. So sodium wants to, so it's going to react with chlorine. Right? It could have reacted with anything. I just chose chlorine. Sodium wants to give away this 1 electron to chlorine. Okay?
Yeah.
So now, look, chlorine has a mass number of 36 and an atomic number of 17. How many protons does chlorine have?
It has 17.
Well done. How many neutrons?
1 second.
It has 19 neutrons. Yeah? Because
Yeah.
remember, its mass number, which is 36, protons plus neutrons give you the mass number. We know there's 17 protons. So 17 plus what gives you
36.
36? Huh? 17 plus what?
17 plus 19 gives you 36.
17 plus 19 gives you 36. All right. So how many electrons does chlorine have?
17.
17. By the way, I know chlorine in your periodic tables, the mass number is 35.5. I've just rounded it to 36. It's not a big deal. I don't care how many neutrons are there anyway right now. Okay. So now chlorine in its first shell, how many electrons is it allowed?
2.
Only 2. The first shell, only 2 electrons. In its second shell, how many electrons am I allowed?
8.
8. Oh, really? I should draw these in dots. So you notice the difference between, do you know what I mean?
Yeah.
So I'm going to draw these in dots. It's known as a dot and cross diagram. Okay.
Yep.
And now we have this last shell. How many are in its last shell? It's allowed up to 8. It's going to have 7. Right? It's only going to have 7. Do you know why? Why, Rachel? It's because we said it has 17 electrons.
Yeah, 17 electrons.
And so those are 17. Now, what's going to happen is when these two elements, when they bond, sodium being the metal, chlorine being the non-metal, the metal always gives away an electron. Yeah? Always. Yep. So this electron is going to go here. Yeah?
Yep.
And so sodium gets rid of that electron and loses its outermost shell. And now its outermost shell is full. So it's happy. And that was the purpose in the first place. Yeah?
Yeah.
So at this point, it becomes an ion. An ion basically means a charged particle. Do you know how it's charged?
No.
What's the charge on a proton, Rachel? It's +1. What's the charge of a neutron? 0, it's neutral. What's the charge of an electron? -1. Okay, Rachel?
Yes.
Atoms by default have no overall charge. Why? Because the number of protons equal the number of electrons. Do you understand that?
Yep.
Because you have 11 positive and 11 negative, so they cancel each other out. So overall, they have no charge. But now, Rachel, sodium has lost an electron. So how many electrons does it have now? It has 10. So it has 11 positives and 10 negatives. So it has an overall 1 + 1 charge. Do you understand?
Yes, I do.
And this +1 charge, we call it a cation. Yeah?
Yep.
Chlorine, right, becomes an ion as well, because an ion means a charged particle, doesn't it?
Yes.
Chlorine becomes an ion, right?
Yep.
And it used to have 17 electrons, but what's happened, Rachel?
It
now has 18. It's gained 1.
Yes.
Right? So chlorine becomes a -1 charge. How? Because how many protons does it have? Chlorine.
Pardon?
How many protons?
17.
17. And it used to have 17 electrons. So the 17 pluses canceled out the 17 negatives and you had overall no charge, right?
Yeah.
But now it has 18 electrons. So 17 and then 18 negatives gives you -1. So it has an overall -1 charge. So we call this an anion. Why? Why is it called an anion? It's just called an anion. But the way I like to remember it, positively charged ions, yeah, are called cations because I like cats. Negatively charged ions are called anions because I don't like onions. An anion sounds like onion. Do you understand that? So
yes,
a cation is a positively charged ion. An anion is a negatively charged ion. Real quick, simple question, Rachel. What is an ion?
An ion is a charged
particle.
Particle.
Well done. An ion is a charged particle. So when we're writing out the chemical formula for sodium chloride, it's NaCl. Question, Rachel, why is it not Na2Cl? Why is it not NaCl2? Because the charges always need to balance out.
Okay.
Sodium made a +1 ion, right?
Yes.
Chlorine made a -1 ion, right?
Yes.
So the charges need to balance out.
Yeah.
Now look, let me show you something. You know, if you look at the periodic table,
yeah,
you know all these metals in group 1. Which group is sodium in?
It's in
group 1. Look, it's right here, bro.
Yeah.
Yeah, you see it's in group 1. That's because whenever they bond, they lose 1 electron and have a +1 charge.
Okay.
Magnesium is in group 2. Whenever it bonds to a non-metal via an ionic bond, it loses 2 electrons and so it becomes a +2 charge.
Okay. I get that part.
In the middle, the reason why they have no groups is because in the middle they're known as transition metals and they make several charges. So you can't really calculate it. And that's why in the exam, the charges are given to you. Do you see these charges that are given to you?
Yes, I do.
Yeah, they're given to you. They're known as transition metals. We'll study them later on. they make several charges when they bond. You can have iron 2, you can have iron 3, and so on. There's different variations. These are known as transition metals. That's why there's no groups for them. Is that good?
Yeah.
In group 3, they all make 3+ charges. In group 4, now listen very carefully now. In group 4, you see it's flipped now, because remember the staircase I drew?
Yeah.
Remember the staircase I drew? What does
Yeah.
the staircase do?
It separates the non-metals from the metals.
Exactly. So this staircase, right? This staircase I've drawn has separated the metals from the non-metals. Now, non-metals,
Yeah.
they always gain electrons, right?
Yeah.
Now, chlorine. Where is chlorine?
It's in group 7.
It's in group 7. And so is it going to make a 7+ charge? That doesn't make sense. It made a -1 charge. No, it has 7 electrons in its outermost shell, and it gains 1 to become a -1 charge, because it wants a full outermost shell, doesn't it?
Yes, it does.
So it wants 8 electrons. It has 7, so it gains that 1. So really, these numbers are the number of electrons it has in its outermost shell. Lithium has 1 electron in its outermost shell. It gives that away to become a +1 charge. Magnesium has 2 electrons in its outermost shell, and when it gives it away, it becomes a 2+ charge. Is that understood?
Yes, I understand that one.
100%.
Yes.
Okay, quick question. Oxygen, when it bonds, what charge is it going to make?
It's gonna make a negative charge.
A negative what?
1.
No, -2. Why? Because it has 6 electrons in its outermost shell, and it wants to gain 2 to make a full outermost shell. Do you understand that?
Oh, okay.
Yeah?
Yeah.
Okay, another question. Nitrogen, when it bonds, how many electrons does it want?
It wants it
It
7.
wants... No, it has 5 electrons in its outermost shell.
Okay.
So it wants 3 electrons to get a full 1. And so when it gets those 3, it becomes a -3 charge. Have I lost you?
Yes.
Okay, I'll explain it. Let's look at nitrogen, yeah?
Okay.
What group was nitrogen in?
Nitrogen was in...
In group 5, yeah?
Yeah.
How many... so the mass number of nitrogen is 14. Its atomic number is 7. How many protons does nitrogen have? 7.
7.
Come on, be confident. How many neutrons?
It has
7, because 7 + 7 gives you 14, right?
Yeah.
How many electrons?
0. Oh, 7.
7, bro. Come on. The number
Sorry.
of protons always equal the number of electrons. Okay? So how many is it going to have in its first shell?
2.
2. Okay?
Yeah.
How many is it going to have in its second shell?
8.
Well, it has only 7 electrons. So how are you going to have 8 electrons in just that shell?
You could just put 7.
No, we have 2 in the first shell. So in the second shell, we're going to have 5.
Okay.
Do you understand that?
Yeah, I do.
Because the first shell can only take 2. And the second shell and every shell after that can take up to 8. Because there's only 7 electrons for nitrogen, we're only going to have 7 in total. So 2 in the first shell and 5 in the outermost shell. Now notice, how many electrons does it have in its outermost shell?
Pardon?
How many electrons does nitrogen have in its outermost shell? 5. Look, 1, 2, 3, 4, 5. Right?
Yes.
And that's why it's in group 5. When it bonds, it wants a full outermost shell. So from somewhere, from another metal, it will gain those electrons that are missing. Do you understand? Sorry, I
Yeah,
drew
I
an extra
understand that.
electron. So because it's gained 3 electrons, it becomes a -3 ion
Okay.
because it's gained 3 electrons. Sorry, earlier I accidentally drawed too many electrons here. Do you get it?
Yeah.
So it should have only been 5 in the outermost shell. So it's gained 3. So now it has a full outermost shell. It becomes a what?
Becomes a negative
Free charge.
charge.
It becomes an anion.
Okay.
Now, whichever the element was that gave it, which is going to be a metal, let's call it X. It doesn't matter. Right? Now, that element, that metal, will have a plus 3 charge because it's lost 3 electrons.
Yeah.
Do you understand that?
Understand.
100%.
I do.
Okay. Our job is to balance these charges. Now, in your exam, you're given this data sheet, yeah, with all of the ions and their charges. Yeah? Okay? Look, you're given this data sheet. Okay, Rachel?
Yeah.
So you can see the charges for a lot of the things. Okay, they're here, right?
Yep.
And a lot of them you can make it out yourself. Like, lithium. What's the charge on lithium here?
It's a plus charge.
It's a +1. And that's going to be obvious because lithium is going to give away 1 electron because it only has 1 electron in its outermost shell.
Yeah.
Like, if we look at a lithium atom, yeah? Right? If we look at a lithium atom, how many electrons does it have in its outermost shell? Just 1. Do you see that 1?
Yeah.
So it's going to give away that 1 to get a full outermost shell. Its first shell, I know you might not think it's full, but remember the first shell can only take 2. So it is full. So some of them, you know them already. Right?
Yeah, I do.
Now, what I want you to is listen to the following, and then it will be well impressive if you can get some of these correct by yourself. Because it's going to be super cool. So, let's do this. Okay, now, listen. We're going to learn how to write chemical formulas. So, let's pick this first example. What does this read?
Sodium bicarbonate.
No, sodium bromide.
Oh, bromide, sorry.
Sodium bromide. That's what it reads. How can we write the chemical formula for this? Well, sodium, right? I don't want you to use the data sheet. I want you to just listen to me for now. Where's my... Okay, if you look at sodium, what group is it in? It's here.
Oh, okay.
It's in group 1, right?
Yeah.
You see that? Let's look at the atomic structure for sodium. Okay?
Yep.
Let's look at the atomic structure for sodium. Here it is. How many electrons does sodium have in its outermost shell?
1.
1. And you see it loses that 1 to become a +1 ion. Do you see that? And that's why if you look on our data sheet as well, sodium has a
+1.
+1 charge. Now, bromine, is here. Do you see bromine?
Yeah.
What group is it in? It's in group 7.
Yeah.
And let's look at the atomic structure of bromine. Yeah? Let's look at it. How many electrons? You can't see that very well. But how many electrons does bromine have in its outermost shell? Count.
7.
Yeah, 7. And it wants a full outermost shell. So how many is it going to accept?
3.
No, it wants a full outermost shell. It has 7 and it wants 8. So it's going to accept only 1, isn't it?
Yeah.
Do you get that, Rachel?
Yeah, I got it.
Was you just bugging out because you thought 7 + 3 is 10?
Yeah, I guess what I was keyboard like the whole thing.
No. We want 8 electrons in its outermost shell.
Oh, now I get it.
Every shell wants 8 electrons in its outermost shell. Apart from the first shell, it just wants 2.
Okay.
Is that understood?
Yeah.
So now look. It's going to accept this 1 electron, right? From who? From sodium. Because sodium has 1 electron, it's going to give it to thing. So because bromine accepts 1 electron, it's only -1 charge. Do you see that?
Yeah.
So sodium is a what charge? +1. Bromine is a what charge? -1.
One. Yeah, I
To
get that.
balance this out, you just need 1 sodium and 1 bromine.
Oh, okay. Now I
And
get it.
that's why it's written as sodium bromide.
Mm-hmm.
Suppose in some sort of world that sodium made a 2+ charge. Yeah?
Yeah.
Then you would need 2 bromines to balance out that 2 pluses.
Yeah.
So it will be written as sodium bromide with a 2.
Okay.
Is that understood?
Yeah.
Now, using the data sheet, right?
Yeah.
I want you to let me know how you write this zinc chloride. Read it.
Zinc chloride.
Now, reading the data sheet, right? Find zinc, find chlorine or chloride, and tell me, first of all, give me the chemical formula for zinc chloride.
Um,
So you'd have to do it in steps. First of all, you'd have to find out, what does the charge zinc makes? What charge does zinc make?
zinc makes a +2 charge.
Well done. So we have zinc +2. What about chlorine or chloride?
Chloride makes a -1 charge.
Okay. Remember this data sheet here you'll have access to.
Yeah.
So what would the chemical formula for zinc chloride be?
The chemical formula would be
Remember, you want to balance out the charges.
okay.
I'm going to give her some time. Okay. So I'm going to help Rachel out a little bit. So zinc makes a 2+ charge, right?
Yeah.
And chlorine makes a -1 charge.
Mm-hmm.
So to balance out this 2+,
Mm-hmm.
you want it balanced, you're going to need 2 chlorines. So you write it zinc chloride like that.
Okay.
You don't put the 2 on the top or like that. You don't put it here. You put it gently right next to this. That
Okay.
like right next to the corner there. So do you understand how the charges are balanced?
Yeah.
Because you have a 2+ from the zinc and chlorine gives you -1, but you have 2 of them. So you have 2 -2, because 2 is positive and 2 is negative, which gives you 0. So the charges are balanced. Is that understood?
Yeah, I guess now I can try do one by myself.
Okay, awesome. So let's pick potassium carbonate.
Okay.
Yeah. So potassium carbonate. Yeah. So
Yeah.
how are you going to do this, Rachel?
So potassium has a 1+ charge,
Yeah, +1 charge.
and carbonate has a -2 charge.
Yeah, 2- charge. Yeah, it's
2
here.
minus charge.
So what are we going to do?
You're trying to balance out the
The positive and negative charges.
yeah.
So what am I going to do?
You're gonna add 2 of the carbonate.
Well, okay, whatever. Let's do that. But if we add 2 of the carbonates, I'm going to have -4, aren't I?
Yeah.
Right?
Yeah, you're gonna have
And we're
negative.
still going to have one plus on the potassium, right?
Mm-hmm.
So how are we going to sort this out?
Um,
Do you want me to help you?
maybe plus maybe add more of the potassium.
Yeah, exactly. Now, if we have 2 potassiums, which we write like this,
Mm-hmm.
now this is going to balance out. Why? Because the 2 potassiums gives us 2+,
Yeah.
and the 1 carbonate has 2-, and they balance out. You see, you get overall 0.
Okay.
Okay?
Yeah.
So the chemical formula now you should know how to write if someone asks you to write out the chemical formula for potassium carbonate, you shouldn't be like, what? How am I supposed to do that? I'm no chemist. Now you should know it's K2CO3. Yeah?
Yeah.
Right?
Yeah, I understand now.
Okay, let's pick another example. Right? Let's pick aluminium sulfate. Actually, that one's a bit difficult. Let's take it easy. Let's do magnesium sulfate. Yeah?
Yeah.
Magnesium sulfate. How are we going to write this?
Magnesium has a +2 charge.
So magnesium has a 2 plus charge. And look,
2
that
plus
makes
charge.
sense as well. Why does that make sense? Because magnesium is in group 2. So if we
Mm-hmm.
look at an atom of magnesium, right? If we look at an atom of magnesium, look how it's drawn. How many electrons does it have in its outermost shell?
2.
2. So it's going to give those 2 away. And it's because it's lost 2 negatives, because each electron is -1 charge, it's going to get a 2 plus charge. Do you understand?
Yeah.
Because magnesium originally, that's its mass number, that's its atomic number. Originally, magnesium has 12 protons, 12 neutrons, and 12 electrons, because the number of protons always equal the number of electrons.
Mm-hmm.
But it gives away 2, so now it has 10 electrons. So it has 12 positives, because each proton is a +1 charge, and each electron is a -1 charge. So it lost 2, so 12 positives and 10 negatives make a +2, overall +2.
Yeah.
Is that understood?
Yeah, I understand that.
So magnesium has a 2 plus charge. What about the sulfate?
Sulfur has a 2 negative charge.
Yeah, 2 minus charge.
2
So
minus
what's the
charge.
chemical formula for magnesium sulfate?
Um, so you're gonna balance it. Supposed to be
Take your time.
it's
So look, they're already balanced. Magnesium sulfate. That's it. That's how we write that. Because the 2 plus balances out the 2 minus. Do you get that? We have 2 plus there, 2 minus there, they balance out. And that's it, magnesium sulfate. Now, for some metals, right? Do you remember those transition metals we spoke about earlier? The big block in the middle.
Yeah.
Those metals make several charges. Look, you know iron, you have iron 2, and it's written in brackets like that. This only happens with transition metals.
Okay.
And that basically means that 2 is Roman for 2. It's Roman numerals, and its value is 2.
Yeah.
So it makes a 2 plus charge. When a transition metal has 3, like this, it makes a 3 plus charge. Right? This only happens for transition metals. You see this business here.
Okay.
Right? So look at our first example now. Look at our first example, lead oxide. Yeah? So lead oxide. Now, you don't even need to know you don't even need to look at the data sheet. You know lead, which, by the way, in the periodic table is Pb. You can look for it. It's right there. Right?
Yeah.
Where is it? I always forget where lead is. Where is it? Yeah, it's right there. Lead. Right? Lead is right there. Now, lead, it's lead 2, so you know it's going to make a +2 charge.
Yeah.
Oxide is right here. It's -2.
Yeah.
So to the chemical formula for lead oxide will just be PbO.
Yeah.
Because they're just going to... Yeah, exactly. Exactly. Right?
Yeah.
Now, I want you to, by yourself now, write out the chemical formula for sodium sulfate. Okay? Sure. So sodium sulfate. So how are we going to do this?
Because sodium is a +1 charge.
Yeah.
And sulfate is a -2 charge.
Yeah. So how are we going to do this?
So you're supposed to balance out the sodium with the sulfate. So you add 1 more of the sodium, which makes it you add 2 sodiums, and then you keep the sulfate as it is.
Well done. Very well done, Rachel. That's very, very well done. So it's sodium sulfate. You done that by yourself?
Yeah.
Right? So we've done a lot now, haven't we? Right?
Yep.
Very well done for this. Very, very well done for getting this correct. Right? Let's do some really tricky ones now. Okay? Because those ones were fun. Let's look at ammonium. And Kwame, I always remember Kwame for this. Ammonium sulfide.
Okay.
So do this with ammonium. Okay. So ammonium sulfide, ammonium sulfide. Do this with me, Rachel. Ammonium is here.
Yeah. Is it do you add one more
Well, hold on.
ammonium?
Let's take it in step. Ammonium's is a +1 charge,
Yeah.
and sulfide is a what?
-2 charge.
Yeah, -2 charge. So what? How are we going to do this?
You add one more ammonium to balance out the sulfite.
Exactly. So we need 2 ammoniums, right?
Mm-hmm.
So the way we write this, NH4, we can't just put a 2 there. That wouldn't make sense. When we have things like this, yeah, where multiple elements are involved instead of just one, like sulfide, we put it in brackets like we do in maths, and we put a little 2 there. Do you get it? It works the same in maths, doesn't it?
Yeah.
And then we just put S, and then that's it. That's done.
Okay.
Okay, do you see that?
Yeah.
Of course, Imran, I want to do one with you. Let me just do 2 more with Rachel, and I'm happy she's understood it. Then I'll do a few with you, Imran, okay? So that's ammonium sulfide. Let's do another one. Let's do calcium nitrate. Okay? By the way, have I mentioned where I got this problem from? I got it from this book here. Yeah? This book, if you're serious about chemistry, especially like proper studying it, I highly recommend this book. If you're only doing GCSE chemistry, separate chemistry, only do the first 3 chapters. If you're doing obviously A-level chemistry, cover the whole thing. If you want to go on to study medicine, you cannot do it without this book. Well, you can, but it'll help you for sure. Jim Clark, Calculations in AS/A-level chemistry. I've got 2 copies of this. I love this book. It's such a good book that one day, my sister and I, we fought over it. And by the way, she studies at King's College now. So she's doing really well as well. And so she used this book as well. It's a very good book. Okay. So calcium nitrate. All right. So Jim Clark, I got this problem from there. Problem 1, Calculations in AS and A-level chemistry by Jim Clark. Right. Okay. I think there's a free PDF version, but get the book. Okay. Get the book. Now, calcium nitrate. How are we going to do this, Rachel?
So calcium first has a 2+ charge.
Right. And that makes sense. If you look at calcium, right?
Mm-hmm.
If you look at calcium as an atom, the atomic structure, right?
Yeah.
It has 2 electrons in its outermost shell, right?
Mm-hmm.
It wants to get rid of those. Once it gets rid of those, it's only left with this shell here.
Yeah.
And then it has a full outermost shell. So when it gets rid of those, calcium has a mass number of 40 and an atomic number of 20.
Mm.
So because it's in group 2, I'm only going to draw the outermost shell. Rachel.
Okay.
Because it's in group 2, it wants to get rid of those 2 electrons.
Yeah.
And so how many protons does calcium have?
40.
Rachel?
Sorry. 20.
How many neutrons?
20.
How many electrons?
20.
Okay. Now, once it's got rid of those, what's its overall charge right now?
Overall charge is
balanced because 20 positives, because each proton is +1, isn't it?
Yeah.
Do you know what I mean? A proton is a subatomic particle. It's a very small thing. And that very small thing has a +1 charge.
Yeah.
Protons and neutrons are inside the nucleus of an atom. And that's why, like, some of these, do you see that middle bit? That middle bit is the nucleus, and it's full of protons and neutrons.
Mm-hmm.
Do you understand? Look at this, right? Each one of those little things, those protons are +1. Electrons, which whiz around in orbitals, they're -1.
Yeah.
Right?
Yes.
So right now, because it's the same amount of protons and electrons, they balance each other out. Because you've got 20 positives and you've got 20 negatives, you're going to get overall 0.
Yeah.
But what's happened is that calcium loses those 2 electrons.
Mm-hmm.
So now it has 18 electrons.
Yeah.
So now it has 20 positives and 18 negatives, which overall leave it with a 2+ charge.
Yeah.
Do you understand that?
Yeah, I get that part.
Okay, so calcium 2+, nitrate. What is nitrate?
It's a -1 charge.
Yeah, so NO3 -1.
Mm-hmm.
What are we going to do here?
So you write the calcium down and you have 2 of the nitrate, but you put the brackets to separate it.
Beautiful stuff. Beautiful stuff, Rachel. Beautiful stuff. Could you believe you could do this by yourself?
No.
At least, well, you could eventually, but not 45 minutes ago, right?
Yeah.
Right. Okay.
Yeah. Thank
One
you.
more difficult one. One more, and then we're going to do it with Imran. Okay.
All right.
All right. One more difficult one. Let's just leave this here. So now let's look at iron. 1, 2, 3. And what's it? Iron hydroxide. Write the chemical formula for iron hydroxide.
Okay. Um,
So iron makes a what charge here?
Iron makes a 3+ charge.
Well done, because of those 3 lines there, right?
Mm-hmm.
It's Roman numerals for 3. So it makes a 3+ charge. What does hydroxide make?
It makes a -1 charge.
OH minus. So then
Yeah.
what are we going to do?
So you put the iron down,
Yeah,
and then you have 2 more of the hydroxide.
almost. Almost. Well, how many of them am I gonna need to balance out those 3 pluses?
3.
Yeah, exactly. So open bracket, OH, and the 3 goes there.
Yeah, that's the answer I have down.
That's the chemical formula for iron hydroxide.
Yeah.
Is that understood?
Understand now.
Okay, awesome. Thank you very much.
Yeah.
All right, so Imran, let's do this one together, okay?
Okay.
So what is this?
So this one is iron 2 and
Iron sulfate, right?
yeah, iron sulfate.
So talk to me.
So first we're gonna have so iron 2 has a +2 charge.
Yeah, so 2+ charge.
Yeah, and then sulfate has a -3.
Look carefully. Look, use your data sheet.
Oh, sorry, -2.
Yeah, -2 charge. So
So we don't really have to do anything. It will just be Fe and then SO4.
yeah, that's it. Iron sulfate.
Yeah.
Right?
Pretty easy.
Let's do another one together, Imran. Okay, that's pretty easy, right? So that's iron sulfate. Let's do another one. Let's do this one here. Copper carbonate, right?
All
So
right.
it says copper.
Yeah, and it has
2.
Yeah, so we has 2+ charge.
Has a 2+ charge because, by the way, this brackets business with the charges and the Roman numerals only happen with transition metals.
Yeah,
So copper 2+ charge, and it even says it here.
and this one's the same thing. Carbonate has -2.
Yeah, -2. So
So it would be what is that? That's a Cu, and then CO3.
yeah, there we go. CuCO3. Yeah. Easy. Let's do aluminium sulfate. This one's super interesting. Watch, Rachel. This one's kind of difficult. So that's copper carbonate, yeah? It's a famous one as well. You guys should know that because it comes up a lot in chemistry GCSE. Aluminium sulfate. So what are we going to do?
This one looks hard, but aluminium has a +3 charge.
Yeah, it's right here, right?
Yeah.
Has a +3 charge. And if you don't know that, you could kind of figure it out because, you know, if you look on your periodic table, Aluminium's in group 3, so it gives away 3 electrons.
Yeah.
Become 3 plus. You can use the data sheet as well. That's cool. And then
And
sulfate.
then sulfate has -2.
Yeah. Oh, so what are we gonna do? Rachel, look.
This looks pretty tricky.
Aluminium 3 plus, but sulfate is -2. Well, we look for the lowest common multiple. No, so look. The lowest common multiple for 3 and 2 is 6, isn't it? Right, Imran?
Oh, yeah.
So you're going to need 2 aluminiums, right? And if you have 2 aluminiums in total, you're going to have a 6 plus charge, aren't you?
Yeah. And then 3 sulfate.
Yeah, you're going to need 3 sulfates because 3 times -2 gives you -6.
Yeah.
It's just a math thing.
Yeah. It's
Yeah. I just want to confirm with Rachel, Imran. Did you understand that, Rachel? Where's Rachel at? Okay, look. I'll explain it one more time. Yeah? Aluminium makes a what charge?
It makes a 3 plus charge.
Sulfate makes a 2 minus, right?
Yeah.
The common multiple between them is 6. To go from 3 to 6, you times by 2, right?
Yeah.
So you're going to need 2 aluminiums. So if you have 2 aluminiums, what's the total charge you have?
A 2 plus charge.
No, a 6 plus, because each one is 3 plus.
Oh.
And now to balance out this 6 plus, because there's 2 aluminiums and each one is 3 plus, we're going to need loads of sulfates. Because if one has -2, another one will have -2, so we have -4, still not balanced. And then another one -2, then we'll get -6. So we need 3 of them in total. And that's the final answer. Did you get that, Rachel?
Yeah, got it.
You'll never get a difficult one like this in the exam anyway, so don't worry. It's more like A levels. Okay?
Yeah.
Do you guys get that?
Yeah.
Okay, guys, I want you to pause the video, have a go at the rest of them, and then when you come back, I'll give you the answers. Okay? Okay.
Yeah.
Guys, those are all the answers for the rest of them. So calcium hydroxide is number 1. Number 2 is cobalt chloride. Number 3 is calcium oxide. Number 4 is silver nitrate. Number 5 is iron fluoride. Number 6 is ammonium nitrate. Number 7 is rubidium iodide. Number 8 is sodium sulfite. Sodium sulfate. And number 9 is chromium oxide. I hope this lesson has been of benefit. I hope you get chemistry better now. Thank you very much, everybody. Bye-bye.